Hello, Workplace Math 10 students. Today we're going to be doing the 10th lesson in graphing, which is about histograms. Histograms tie in well with the last lesson we learned about tally charts, basically because the tally charts allow us to organize sets of data into categories or bins, which we can then graph into graphs that are called histograms. So let's take a look at what this looks like. So basically, a histogram is, as we said here, connected with tally charts. And so just as a bit of a review as to what we've done so far, we have already talked about line graphs, we've talked about bar graphs, we've talked about pie graphs, and we've talked about pictographs. And last lesson, we looked at tally charts, which allow us to take a set of data and just basically determine how many numbers are in each, how many times each number occurs. When we have that type of information, we can then easily make what is called a histogram. And a histogram is essentially like a bar graph, except that it is showing specifically categories or bins of data. So let me show you an example of what I'm talking about here. So basically a histogram, this is an example of a histogram. So what we can see is there are a range of values here. So if we asked how many runners are younger than 31, this graph is showing us here basically what the age categories are of all the runners. So some runners are in the age category from 11 to 20, some are in from the age category of 21 to 30, some from 31 to 40, some from 41 to 50, and some all the way from 51 to 60. But it's showing us a range. And so histograms, as you can see, provide a visual interpretation, in other words, a visual representation of numerical data by indicating the number of data points that lie within a range of values. In other words, how many of those numbers were between 11 and 20? Well, according to this graph, 2 were in the range between 11 and 20. And when we talk about these various ranges of values, we are talking about setting them into bins. So in this case, the person who made this graph decided to set the bins as, age categories of 10. So from 11 to 20, from 21 to 30, and so forth. In most common forms of histograms, the independent variable is plotted along the horizontal axis. In other words, the thing that is not dependent on anything else is the person's age. But what is dependent on that is how many people fall within that age category, and that is on the vertical axis, and that in this case is the number of runners that fall within each of those age categories. So let's take a look at what your actual mathletics assignment is going to look like, the histogram assignment. This is not a particularly hard assignment in my opinion, but let's take a look at what it's showing us here. So the first one is, it's asking us which age interval has 8 runners. Well, if we look at this, the number of runners is shown on the vertical axis here. This is the number of runners. This is the vertical axis. And when we look at 8, the one that connects with 8 is this one here. So the blue one here is the one that has 8 runners. And so therefore the age category, the age interval that fits with that is 31 to 40. So hopefully that makes sense to you. Let me just come back here to this again, and let's take a look at the next question. So it says here, now how many runners are younger than 41? Well, this one is a little bit more involved because basically what we see is that this category and this category include runners that are not younger than 41. In other words, they're 41 or older, these two. But all of these, so this one, and this one, include runners that are younger than 41. So if we look at this though, this one here, this age group has 5, this age group has 9, and this age group has 7. So if we add those 3 occurrences together, 7 plus 9 plus 5, we add those together, we are going to come up with a value of 21. So let's just double check to see that. Let's just go to our calculator to make sure. But basically we're going to plug in there the values of 7 plus 9 plus 5, and that's why we got that value of 21. So if we come back in here, we can see that this is why we got that value of 21, why that's correct. Now, let's take a look at another one that's very similar, but just basically asking how many runners are older than 20 now. So once again, when we look at the age of runners that are older than 20, the only one that is not older than 20 is this one here. So that one doesn't fit. But any of these 4 columns do fit because all of these people are over the age of 20. So basically this one here shows that there are 3 runners in this age category. There is 1 runner in this age category. There is 7 in this age category, and there is 8 in this age category. And once again, I'm just looking across to see how many this is represented by. So now if I take those 4 values, 3 plus 1 plus 7 and plus 8, when I add all those up, that is going to come to a value of 19. And just to confirm in our calculator, let's just plug it in there to just see. But basically what we're going to have is we're going to have the 3 plus the 1 plus the 7 plus the 8, which adds up to 19. And that is why when we came back in here that we see that that answer of 19 is correct. So hopefully that makes sense. There's not a whole lot else to this exercise. I don't think you should find it too difficult, but if you have any questions, please don't hesitate to ask. Thanks for watching.